Hi grade 7! For today, our topic is differentiating algebraic expressions, equations, and inequalities. Illustrating linear equation and inequality in one variable. And it was based on MATH7, Quarter 2, Module number 8.
This is from LRMDS Bulacan. Thank you and congratulations to the development team of this module. Credit to the author, language reviewer, content editor, illustrator, and layout artist of this module.
Hi math lovers! Are you ready? Let's learn! Have fun! Because mathematics is fun!
What I need to know.
This module provides varied activities that will help you to learn about the equations and inequalities in one variable. At the end of this module, you are expected to number 1, differentiate algebraic expressions, equations, and inequalities. Number 2, illustrates linear equation and inequality in one variable. Number 3, translate verbal phrase into mathematical phrase involving linear equation and inequality in one variable. And number 4, write the given linear equation into the form of ax plus b is equal to 0.
What I know. Turn your module to pages 3 up to 5. Let's answer the pretest. Read each item carefully. Write the letter of the best answer in the blank provided before each item. What's in? Match the verbal phrases to mathematical expressions. First, 7 is greater than 5. Now choose among the given expressions. The answer is this expression. 7 is greater than 5. Let's proceed to number 2. 9 subtracted from y. Now choose among the given expressions. Our answer is y minus 9. We have to change the position of y and 9 because of the word subtracted from. Example number 3. 10 added by 2 is 12. Now choose among the following expressions. The answer is 10 plus 2 equals 12. Now let's proceed to the next one. 7 subtracted 12 is less than 8. Now choose among the given expressions. Our answer is 12 minus 7 is less than 8. Example number 5. The sum of x and 3. Now choose among the given expressions. Our answer is x plus 3. Example number 6. The product of 2 and a. Choose among the given expressions. The answer is 2a. Let's proceed to example number 7. The difference of y and 8. Now choose among the given expressions. Our answer is y minus 8. Example number 8. 25 is greater than 16. Now choose among the given expressions. The answer is this expression. 25 is greater than 16. Example number 9. 5 subtracted from 12 is 7. Now choose among the given expressions. Our answer is 12 minus 5 is equal to 7. Again, we have to change the position of 12 and 5 because of the word subtracted from. Now proceed to our last example. 24 is less than 52. Now choose among the given expressions. The answer is this expression. 24 is less than 52. What's new?
What is the graph of linear equation and inequality in one variable? We have here a clue. Two words with 8 and 4 letters. To answer the equation, solve the mathematical expressions. Write the letter inside the box above each ordinal number. The ordinal in alphabet is equal to your answer. For example, number 5, that is letter E.
Now let's answer the question using the clue. Twice 8 added by 3. We have 2 times 8 plus 3. Then 2 times 8 is equal to 16 plus 3. And that is 19. And the 19th letter in the alphabet is letter S. The next one is the sum of 8 and 12. We have 8 plus 12, and that is 20. The 20th letter in the alphabet is letter T. Next is the difference of 24 and 6. (24 minus 6 is equal to 18. The 18th letter in the alphabet is letter R. Our next expression is 24 subtracted from 25. Because of the word subtracted from, we will change the position of 24 and 25. We have 25 minus 24 is equal to 1. The first letter in the alphabet is letter A. Next is the sum of 4 and 5. (4 plus 5 is equal to 9. The 9th letter in the alphabet is letter I. Next we have 18 diminished by 11. That is 18 minus 11 is equal to 7. And the 7th letter in the alphabet is letter G. The next expression is 6 increased by 2. 6 plus 2 is equal to 8. And the 8th letter in the alphabet is letter H. Next we have 2 times 6 increased by 8. We have 2 times 6 plus 8. Then we will multiply 2 and 6. That is 12 plus 8. And 12 plus 8 is equal to 20. And the 20th letter in the alphabet is letter T. Now let's proceed to the second word. 3 times 6 diminished by 6. We have 3 times 6 minus 6. The product of 3 and 6 is 18. And 18 minus 6 is equal to 12. And the 12th letter in the alphabet is letter L. Let's proceed to the next one. 21 subtracted by 12. 21 minus 12 is equal to 9. And the 9th letter in the alphabet is letter I. The next expression is 8 added to 6. We have 8 plus 6 is equal to 14. And the 14th letter in the alphabet is letter N. For our last letter, we have 3 subtracted from 8. Because of the word subtracted from, we will change the position of 8 and 3. Now we have 8 minus 3 is equal to 5. And the 5th letter in the alphabet is letter E. To answer the question, what is the graph of linear equation and inequality in one variable, our answer is straight line. What is it? Lesson number 1. Algebraic expressions, equations, and inequalities.
An equation is a mathematical sentence indicating that two expressions are equal. The symbol equal is used to denote equality. Example, 15 plus 6 equals 21. 11 minus 8 equals 3. 2 times 5 equals 7 minus 3. 9 over 3 plus 1 equals 2 times 2. An inequality is a mathematical sentence indicating that two expressions are not equal. The relation symbols are less than or equal, greater than or equal, and not equal are used to denote inequality. Example, 24 is greater than 11 plus 1. 8 times 4 is less than 35. 30 plus 5 is not equal to 42 minus 9. Algebraic expression is a variable, a constant, or a combination of both which may be related to any of four fundamental operations. An algebraic expression does not require the use of an equal sign or an inequality symbol. For example, x plus 5, 2m minus 3, 6y plus 1, 7 minus 2x, 3y, 12 plus 6x minus 2x.
Lesson number 2. Linear equation and inequality in one variable.
First, let's try to differentiate equation and inequality based on its definition. Equation is a statement in which two expressions, at least one containing the variable, are equal. The expressions are called the sides of the equation, while inequality is a mathematical sentence which states that two expressions are unequal. Now let's try to differentiate the two using the symbol. For equation, we use equal sign. For inequality, we use inequality symbol such as less than, greater than, less than or equal to, greater than or equal to, and not equal. Now let's differentiate using the number of solutions. For equation, we have exactly one solution. Example, in x equals 3, the solution is only 3. In inequality, we have many solutions. In x is greater than 3, the solutions are all numbers greater than 3, such as 4, 5, 6, and so on. Now let's give example for each term. For equation, we have x plus 5 equals 8, where x is 3. We can identify the expression. For inequality, x is greater than 3. The value of x are all numbers greater than 3. Now let's differentiate the terms using the graph. For equation, we have x equals 3. We have exact solution in the graph. That is in number 3. For inequality, we cannot identify the exact location of the term. X is greater than 3. X is greater than or equal 3. X is less than 3. X is less than or equal 3. A linear equation in one variable is an equation which has a maximum of one variable with the highest power of 1. This equation has only one solution. For example, 5x equals 1. 17x minus 1 equals 0. 3x minus 6 equals negative 11.
Let us try to identify whether each of the following example is a linear equation in one variable or not. Let's have example number 1. We have x plus 6 equal to 0. How many variables are there? We have x and that is 1. What is the highest point or power of the variable in the example? Based on the exponent, we have only 1. What is the relation symbol used in the example? That is equal sign. Is it a linear equation or not? Yes or no? Yes, that is an example of linear equation. Example number 2. 2x minus 3 is equal to 0. How many variables are there? We have letter y and that is only 1. What is the highest exponent or power of the variable in the example? Our exponent is 1. What is the relation symbol used in the example? That is equal symbol. Is it a linear equation or not? Yes or no? Yes, this is an example of linear equation. Let's proceed to example number 3. A is equal to 0. How many variables are there? We have a and that is 1. What is the highest exponent or power of the variable in the example? Our exponent is 1. What is the relation symbol used in the example? We use equal symbol. Is it a linear equation or not? Yes or no? Yes, this is an example of linear equation. Example number 4. X plus 2x is equal to 4. How many variables are there? We have this x and this x. That is 1 because they are just the same letter or variable. What is the highest exponent or power of the variable in the example? We have only 1. First, because they are similar term. Second, because of the operation. X plus 2x is equivalent to 3x. What is the relation symbol used in the example? We used equal symbol. Is it a linear equation or not? Yes or no? Yes, this is an example of linear equation. Example number 5. M squared minus 2 is equal to 4. How many variables are there? We have m and that is 1. What is the highest exponent or power of the variable in the example? Our exponent is 2. What is the relation symbol used in the example? We use equal symbol. Is it a linear equation or not? Yes or no? No. This is not an example of linear equation because of the exponent 2. Example number 6. 3f is greater than 4. How many variables are there? We have f and that is 1. What is the highest exponent or power of the variable in the example? The exponent is 1. What is the relation symbol used in the example? We use greater than. Is it a linear equation or not? Yes or no? No, because of the inequality symbol greater than. Example number 7. Y minus 1/4 is equal to 0. How many variables are there? We have y and that is 1. What is the highest exponent or power of the variable in the example? The exponent is 1. What is the relation symbol used in the example? We use equal symbol. Is it a linear equation or not? Yes or no? Yes, this is an example of linear equation. Example number 8. X over 2 plus 6 is equal to 1. How many variables are there? We have x and that is 1. What is the highest exponent or power of the variable in the example? Our exponent is 1. What is the relation symbol used in the example? We use equal symbol. Is it a linear equation or not? Yes or no? Yes, this is an example of linear equation. Example number 9. 2 over x plus 6 is equal to 1. How many variables are there? We have x and that is 1. What is the highest exponent or power of the variable in the example? Our exponent is 1. What is the relation symbol used in the example? We use equal symbol. Is it a linear equation or not? Yes or no? Yes, this is an example of linear equation. For our last example, we have x over 2 plus 6 over x equals 0. How many variables are there? We have x and another x. But that is only 1 because they are similar. What is the highest exponent or power of the variable in the example? We have here and here. We have 2. We can't combine them because they are not similar terms. First, we need to get the LCD to find the sum. Our LCD is 2x. Changing them to similar terms, we have x squared plus 12 over 2x. So our exponent is 2. What is the relation symbol used in the example? We use equal symbol. Is it a linear equation or not? Yes or no? No, because of the exponent 2. Lesson number 3. Standard form of linear equations in one variable.
The standard form of linear equation is ax plus b is equal to 0, where a and b are real numbers. A is not equal to 0.
Let us change each equation to standard form of linear equations in one variable. First, let's try this one. X plus 2x is equal to 4. Equate the right side of the equation to 0. Apply the addition property of equality or APE. The opposite of the term at the right side is negative 4. So we will add negative 4 on both sides of the equation. Add negative 4 to the left and negative 4 to the right. Combine similar terms on the left side of the equation. First, let's cancel out the numbers at the right side to make it 0. Now we can combine x plus 2x. Because they are similar terms, we have 3x minus 4 is equal to 0. Write in the form ax plus b is equal to 0, where a is a whole number. Then identify the values of a and b. 3x minus 4 is equal to 0 is in standard form, so we can get the value of a and b. So we have a is equal to 3 and b is equal to negative 4. Let's have example number 2. X over 2 plus 6 is equal to 0. Evaluate the right side of the equation to 0, then apply the addition property of equality or APE. The opposite of the term at the right side is negative 1. We will subtract negative 1 on both sides of the equation, on the left side and on the right side. Combine similar terms on the left side of the equation. First, we will cancel out 1 to make it 0. Then we will combine 6 and negative 1. We have x over 2 plus 5 is equal to 0. We need to simplify x over 2 to get the value of a and b. We need to apply the multiplication property of equality or MPE. First, let's get the LCD, and that is 2. We will multiply the LCD on both sides of the equation, giving us the product of x plus 10 is equal to 0. Now write in the form of ax plus b is equal to 0, where a is a whole number. Then identify the values of a and b. X plus 10 is equal to 0 is in standard form, so we can get the value of a and b. A is equal to 1 and b is equal to 10. Just remember, any variable without numerical coefficient is equivalent to 1. Example number 3. We have 2 over x plus 6 is equal to 1. Equate the right side of the equation to 0. Apply the addition property of equality or APE. The opposite of the term at the right side is negative 1. So we will add negative 1 on both sides of the equation. We will add to the left and add to the right. Combine similar terms on the left side of the equation. First, we will cancel out 1 to make it 0. Then combine 6 and negative 1. We have 2 over x plus 5 is equal to 0. Write in the form of ax plus b is equal to 0, where a is a whole number. Then identify the values of a and b. So we need to simplify the term. Apply the multiplication property of equality or MPE. First, get the LCD. Our LCD is x and we have to multiply it on both sides of the equation. That is 2 plus 5x is equal to 0. Or changing it to the right format, we have 5x plus 2 is equal to 0. Now we can get the value of a, that is 5, and b is 2. Example number 4. We have x over 2 plus 6 over x is equal to 0. Step 1, the right side of the equation is already equal to 0. Step 2, there is no similar terms to combine. Step 3, make the value of a whole number by multiplying both sides of the equation by the LCD, which is 2x. Now let's apply the distributive property of multiplication or DPM. We will multiply x over 2 plus 6 over x is equal to 0 to its LCD, which is 2 over x. We will multiply each term. We have 2x squared over 2 plus 12x over x is equal to 2x times 0. After simplifying the term, we have x squared plus 12 is equal to 0. After trying to write it in the form of ax plus b is equal to 0, you will notice that the highest power of a variable x is 2. Therefore, x over 2 plus 6 over x is equals to 0 is not an example of a linear equation. Thus, writing an equation in the form of ax plus b is equal to 0 helps you identify whether the given equation is a linear equation in one variable or not. Lesson number 4. Translating verbal statement into a mathematical statement involving linear equation and inequality in one variable.
In translating verbal statement into mathematical statement, it is important to know the words that are used to indicate mathematical operations. For example, addition. We can change this into plus, more than, increased by, the sum of, the total of, added to, and added by. For subtraction, we can use minus, less than, decreased by, the difference of, subtracted from, subtracted by, and diminished by. For multiplication, we can use times, twice, thrice, multiplied by, and the product of. For division, we can use divided by, the ratio of, and the quotient of. In identifying whether the given verbal phrase is an equation or inequality, we have different words that will help us to find it easily. The verbal statement is an equation if it uses the word is before a number or an algebraic expression. A verbal statement is an inequality if it uses the word is less than, is greater than, is at least, or is at most before the number or an algebraic expression.
Let's have example number 1. X added by 6 is 10. First, just bring down x. The symbol for added by is plus sign. Then bring down 6. The word is equivalent to equal. Then bring down 10. Translating this into mathematical equation, we have x plus 6 is equal to 10. Example number 2. X less than 6 is greater than 10. First, bring down x. The symbol for less than is subtraction. Then bring down 6. The symbol for is greater than is this symbol. Then bring down 10. Translating this to mathematical equation, we have x minus 6 is greater than 10. Example number 3. Twice y subtracted by 4 is 12. Thrice y is equivalent to 2y. Subtracted by is subtraction symbol. Then bring down 4. The word is equal symbol. Then bring down 12. Translating this into mathematical equation, we have 2y minus 4 is equal to 12. Example number 4. Y subtracted by 4 is less than 12. First, bring down y. Subtracted by is subtraction symbol. Then bring down 4. The word is less than is equivalent to this symbol. Then bring down 12. Translating this to mathematical equation, we have y minus 4 is less than 12. Example number 5. 3 subtracted from m is thrice m. First, bring down 3. Subtracted from is subtraction. Then bring down m. We need to change the position of 3 and m because of the word subtracted from. This will become m minus 3. Now the word is equivalent to equal. Thrice m is equivalent to 3m. Translating this into mathematical equation, we have m minus 3 is equal to 3m. Example number 6. 12 diminished by x is at least 5. First, bring down 12. The word diminished by is subtraction. Then bring down x. The word is at least is equivalent to this symbol. Greater than or equal to. That is because of the word is and least. Then bring down 5. For translation, we have 12 minus x is greater than equal to 5. Example number 7. 6 times x increased by 4 is 1. 6 times x is equivalent to 6x. The word increased by is addition. Then bring down 4. The word is equivalent to equal. Then bring down 1. For translation, we have 6x plus 4 is equal to 1. Example number 8. The ratio of x and 2 is at most 1. The phrase, the ratio of x and 2 is equivalent to x over 2. And the word is at most is equivalent to this symbol, less than or equal to, because of the word is and most. Then bring down 1. For translation, we have x over 2 is less than equal to 1. Example number 9. 7 added to y is twice y. First, bring down 7. The word added to is equivalent to addition. Then, bring down y. Now we have to change the position of 7 and y because of the word added to. Now we have y plus 7. The word is equivalent to equal. And twice y is equal to 2y. In translation, we have y plus 7 is equal to 2y. Example number 10. X added by 6 is 10. First, bring down x. The phrase added by is addition. Then bring down 6. The word is equivalent to equal. Then lastly, bring down 10. In translation, we have x plus 6 is equal to 10.
Are you ready to answer your module? Good luck!
What's more, Independent activity number 1. Turn your module to page 12. Identify whether each example is an algebraic expression, an equation, or an inequality. Write the given examples under each corresponding column on the table that follows. Independent assessment number 1. Turn your module to page 13. On the blank provided before each number, draw a circle if the given verbal phrases expresses an algebraic expression, square if the verbal phrases expresses equation, and triangle if the verbal phrases expresses an inequality. Independent activity number 2. Turn your module to pages 13 and 14. For letter A, identify the graph of the given linear equation and inequality in one variable. Match the linear equation or inequality in column A with the graph in column B. Write the shapes that corresponds to your answer on the space provided before each number. For letter B, complete the table below. The first one is done for you. Independent assessment number 2. Turn your module to page 14. For letter A, illustrate the graph of the solution on the given linear equation and inequalities in one variable. Use the number line in each item. For letter B, write the following linear equation in one variable in its standard form. Ax plus b is equal to 0. Then identify the values of A and B. Independent activity number 3. Turn your module to page 15. On the first column before each number, draw a happy face if the mathematical phrase is correct for the given verbal phrase. If not, draw a sad face instead. Independent assessment number 3. Turn your module to page 15 and 16. Translate the given verbal phrases into mathematical phrases. Write your answer on the blank provided for each number. What I have learned. For what I have learned, turn your module to page 16. Rate your understanding from the lesson discussed in this module and explain it in 2 to 3 sentences. Can you give an example of real-life situation which can be related to these lessons? Write your example below. What I can do. For what I can do, turn your module to pages 16 and 17. First, read the paragraph above. To reveal the Newton's third law of motion, arrange the jumbled letters inside the box. Assessment. Turn your module to page 17. Let's answer the post-test. Put a check mark on the blank provided before each number if the statement is correct. Otherwise, put a cross mark. Additional activity. Turn your module to page 18. Match the linear equation in one variable in column A with its standard form in column B. Write the corresponding letter inside the box above to reveal the name of the mathematician. References.